Okay, hello everyone, welcome back, and I hope you have a nice weekend. In the last week, we have a midterm, and we also moved to the SQL sections, and I hope you're doing very good in the midterm. And the grading of the midterm will be finished in a few weeks and by the TA, and you can also talk with the TA, the annex, if you have any questions about the homework 2 and the midterm. And in the last week, we talked about the SQL, the basics. And I have some clarifications for the materials we covered in the last week. So first of all, we need to have a semicolon denoting the end of a query, and the where clause can be optional. What does this mean? In the last week, we have talked about this select from where this statements. At the end, we need to have this semicolon denoting the end, even though in some examples we didn't show this semicolon in the slides. But this is a must. It is required by the grammar of the SQL. And the where clause can be optional because sometimes we don't require this where clause since we have no conditions for the query. And if so, then this where clause can be optional, can be removed. Another thing I'd like to clarify is for the strings in SQL. In the last week, we showed an example with a wrong template or wrong formats. So for the strings in SQL, we need to use a single quotes. What does this mean? I also provide you with an example like select beer from the next table where the drinker equals to phrase father. So for the string, the phrase father is a string, right? We use a single quotes denoting it as a string. And since inside the string, we need to use this single quotes. However, we use this double quotes to denoting it is a single quote inside a string. So therefore, here the phrase father we use this double quotes instead. It denotes a single quote inside a string. So these are 2 points we need to clarify for the materials we covered in the last week. And you can also practice them with your SQL installed on your computer, or you can also practice with this SQL Zoom. The website will provide you with a link in the last week in the emails as well as in the lectures. Okay, so for a schedule about this week, we plan to finish the SQL Basics. We have 2 classes on the SQL Basics, and then we also plan to finish this SQL modifications. Generally, after we finish this week, you should be able to do your homework. And we have a reminder for you as well. And we have a stage 3 for the project will be due by Friday. So please remember to submit the report in one single PDF document to be uploaded to the Canvas system. We also release the homework 3 in a schedule spreadsheet, and you can access the homework 3. Also remember to do it, and we have a deadline to be due by the next Friday. Okay, so this is for the schedule. And let's come back to the lectures. So in the SQL materials we covered in the last week, we can write some basic select from where statements. And these statements generally they are operating based on some relations or tables. However, sometimes we may have some cases and we have to run the select from where clauses or statements based on the intermediate result we get from some other statements. If so, then we need to introduce another very important concept. It's called subquery. So formula a parenthesized select from where statement, the subquery, can be used as a value in a number of places, including both the from and the where clause. What does this mean? Before we mentioned that in the from and the where clauses, for the from we need to work on some relations, right? For the where clause, we need to work on some conditions. And they are also based on the relation, right, in the from clause. If we want to run a select from where statements based on an intermediate result from another statement, if so, then we can use this intermediate result as a subquery. And they can also be used in some other select from where statements. So we can also provide you with some examples. Now, in the place of a relation in the from clause, we can place another query and then query the result. To use this query as an intermediate result, we can also use a tuple variable to name tuples of the results. And sometimes the subquery we get, the result can actually be scanners. Normally we mention that for select from where statements, the result will be a relation, will be a table, right? However, sometimes if we can guarantee the subquery can produce one single tuple with one single attribute, then the subquery can be used as a value, right? So what does this mean? Before we mentioned that select from where these statements, they will return a table, right? They will return a table, something like this, right? We can get a table. Inside table, we have some desired attributes, right? And this columns denoting the desired attributes 1, 2, 3, right? And the rows denoting the tuples matching the conditions, right? And the rows denoting the tuples matching the condition in the where clause. And sometimes if we have one single desired attribute, in other words, the returning result has one single attribute, and we can delete all the other columns. And at the same time, we can also guarantee that we have only one single row in the returning result. In other words, besides this name of this attribute, we have one single data tuple in the return result, right? It is still a table. However, this table containing one single row and one single column. If so, then we can use this returning table, this tiny table, as a value in some other queries, which is as described here. These subqueries can return scanners. And normally we need to guarantee that the returning result has one single row and one single column. If we can guarantee so, then we can use it as a value or a scanner. This single tuple can often be guaranteed by the key constraints. We can use a key constraint in the conditions to guarantee the returning result can be a value. If you plan to use this subquery as a scanner, please be careful because a running error may occur if there is no tuple or more than one tuple. If in the return result we have multiple tuples, multi-rows, then we cannot use this return result as a value, right? If in the return result we have no rows, no tuples at all, then this table will be empty, right? We cannot use it as a value neither. So please be careful if we use this subquery as a scanner. So this is about subquery, and we'll provide you with an example how to use subquery to help us. In this sim, we have a question from the sales table with bar B and price. Please find the bars that serve the miner, the B and M, miner, for the same price as Joe's bar charges for Bud. Before you see the answers, please try to do this query by yourself first. So we have different ways to do this query, right? If you still remember, before we mentioned that we can use the same sales table multiple times to do this query. If we use the multi-relation SQL or the select from where statements, how we do this question? Okay, so if we do this query with this multi-relation SQL statements we learned from the last class, we can do the query very easily, right? We can do so by writing down the statements as follows. We select the bar name, right? Because we will use this sales table multiple times, so we can do so by writing down s1.bar from sales s1 and sales s2, right? We use this same table multiple times. Where what? Well, s1 dot beer equals to miner, and s2 dot beer equals to what? Equals to Bob, and s1 dot price equals to s2.price. And what? And s2.bar equals to what? Equals to Joe's bar. And then we have semicolon. So this is a statement we can learn from the last class, right? For using the same sales table multiple times, we also rename it with S1 and S2 as the names. So we need to require S1.beer should be the meaner, right? S2.beer should be bought, and S2 bar should be Joe's bar, right? And they say the beers with the same price. And then we can return the S1.bar, denoting the bars which serve the meaner for the same price as Joe's bar charged for bought. Okay, so this is a SQL. This is the statements we can write down based on what we learned from the last class. You can also wonder, besides the answer like this, can we have any other potential answers? The answer is yes. We can also use the subquery to help us. So what do I mean? So if we check the question again from the sales table, find the bars that serve the meaner for the same price as Joe's bar charged for bought. If we want to answer this question, the first one, you may wonder what is the price that Joe's bar charged for bought, right? If we can have price, then we can use this price as an intermediate result to help us find the bars which serve the meaner with the same price, right? Then it provides us with a hierarchical thinking for writing down queries in SQL. So the first question will be to find the price Joe's bar charges for bought, right? And the second question will be to find the bars that serve meaner at the same price. If we think in this way, then we have to use this subquery to help us. So to find the price that Joe's bar charges for bought, we can write down the select from where statements as shown at the bottom. We select the price from the sales table where bar equals Joe's bar and a beer equals to bought. This statements will return the price that Joe's bar charged for bought, right? And at the same time, we can also guarantee the return result contains one single column and one single row. In other words, we can use this intermediate result as a scanner. So remember, we have parentheses. This parentheses denoting this statement denoting a subquery, and we use this price equals to parentheses with the select from where statements as in bottom. We are matching the price with the return result from this statement. Then we can do the second question, find the bars that serve the meaner at the same price. So we can do by select bar from sales table where the beer equals to meaner and price equals to the return result of this subquery. So we need to have this parentheses, this denoting the subquery. So this is about the subquery. It can be very helpful for us to work on some very complex queries, and we can simplify this query into multiple subqueries to help us. Also remember, if we use this return result as a scanner, we will make sure it contains one single row and one single column. Then we can use it as a scanner, right? Okay, this is about the example.